This is ASPure notes. We're on Unit 8, which is trigonometry, and we're taking a look then at trigonometric functions for any angle. So we're dealing with the cast diagram here, going from 0 all the way around then to 360. In trigonometry, we assign angles to the 4 quadrants. So the first quadrant is 0 to 90. We don't need to worry about this. This is now an A2. It's a different way of measuring our angles. Second, 90 to 180, third 180 to 270, and fourth 270 to 360, and we measure then from 0. Angles are measured from 0 degrees in the diagram. Consider the graphs of sine x, cos x, tan x. We can determine the signs of each ratio in each quadrant. I'm just going to do some tiny wee diagrams here so you can get an idea. The graph of sine between 0 and 360 looks like that. So that's the graph of sine. The graph of cos looks like that. And then the graph of tan looks like that. So between 0 and 90, sine is positive, cos is positive, and tan is positive. So sine x is positive, cos x is positive, and tan x is positive. If you look at the graphs between 90 and 180, sine is still positive, cos is now negative, and tan is negative. So sine x is positive, cos x is negative, and tan x is negative. If you look between 180 and 360, sine is negative now, cos is negative, and tan is positive. And then finally for the last quadrant, that's negative, that's positive, that's negative. So sine x is negative, cos x is positive, and tan x is negative. And that's where our cast diagram comes from. They're all positive. Sine is positive, tan is positive, and cos is positive. So saying it's cast diagram going round that way there. Special angles, again, you should be familiar with these and be able to work them out. So we have a couple of different wee ways of kind of working them out. We can kind of do it by doing our diagrams. So we need to do a wee, if I do an equilateral triangle and split it in two, and if I make each of the sides of this 2, that would be 2, that would be 2, and that then would be 1, that wee distance there, so that's 1 and 1, and we know that that's 60, and I've split that one in half, so then that would be 30. If you do Pythagoras for this wee side here, then you would get root 3, and that helps us to work out our sine, cos and tan of 30 and 60. For the 45 degree one, if I make again an isosceles triangle 1, 1, and then that would be root 2. Sine of 0 is 0, cos of 0 is 1, tan of 0 is 0. 30 degrees, sine is opposite over hypotenuse, so that'll be a half. Cos is adjacent over hypotenuse, so it'll be root 3 over 2, and then tan is O over adjacent, so it's 1 over root 3. 45 will go to this one, so sine is 1 over root 2, cos is the same, 1 over root 2, and tan then is 1 over 1. For 60 then we're looking at this angle, opposite over hypotenuse, so that's root 3 over 2. Notice that's the same, so it's not over root 2, it's just over 2. 3 over 2. And notice that's the same then as, so cos of 30 is the same as sine of 60. Cos of 60 is then adjacent over hypotenuse, so that's a half, and then tan of 60 is root 3 over 1, so that then is root 3. And then sine of 90 is 1, cos of 90 is 0, and then tan of 90 is undefined, because it heads off then to infinity. Write down the value of the following in surd form without a calculator. So from the graph, sine 120 is equal to sine 60. So in that case, that's going to be root 3 over 2. Cos of 120 is the same as minus cos of 60, and in that case then it's going to be minus